Kule video le funa sibheke ama-acid and base reactions, right? So if we have a reaction between an acid and a base, we call this reaction a neutralization reaction. So meaning if a base and an acid react, they are neutralizing each other. So it's a neutralization reaction, right? So we have three situations of the resulting solutions, because kahle nas react acid ne base kahle la we want to answer two questions. The first question is sifuna ukubheka ukuthi the resulting solution naso wahlanganisile le acid nale base, depending on the amount of the acid nale base, the resulting solution, is it neutral or is it acidic or is it basic, right? So ilama situations are three. Esifuna ukubheka ukuthi which situation will result nasihlanganisa le acid nale base. Is it neutral, is it acidic, or is it basic, right? And number two, after determining whether it is neutral, acidic, or basic, then we can determine the pH of that resulting solution, right? Okay, so we said if we react an acid and a base, so in this case sizothi acid here to this light blue. Yeah, this is the acid, and then our base sisebenzisa ipaper. Right? Okay, so sizothela le acid nale base in one container to react them. So the first situation, which is the neutral solution. So now I container yethu la sithela le acid phakathi, right? Sithela phakathi le acid bese sithela le base phakathi la, and then we leave this to react, right? So nase reactile sesithola ukuthi le acid yonke i-reacte nale base yonke. So that is complete neutralization. So it means the resulting solution is neutral, right? Means yonke le acid le i-reacte nayo yonke le base. So in this case, the resulting solution will be neutral, and the pH yakhona is 7, right? That is situation number one. And then situation number two, you can have container yakhona ila, right? Uthela le acid yonke phakathi la, and then so uthela nale base yakho phakathi la, ufuna ukuthi lezi two si react, right? But then now so uthola ukuthi okay, maybe for example senzeka so uthola ukuthi akusiyo yonke le acid e-reactayo lapha, right? Akusiyo yonke le acid e-reactayo. So but le base i-reacte yonke. So le base le ela asithi i-reacte maybe na this portion of the acid yaphela base, right? So base iphelile ke manje la. So as you can see la, we still have an extra amount of the acid right? Which is this portion. This portion is still the acid that remains inside that solution after the neutralization, right? So we have an extra amount of the acid, which is excess acid. So in this case, it means the resulting solution, the solution layer at the end of the day, it will be acidic. It will still be acidic because we have an excess of acid reactang. And what can we conclude about our pH? So we can say our pH in this case, it is less than 7, and medicine calculate here, because remember we are answering two questions. We want to check the resulting solution, right? And then we calculate the pH. So if there is complete neutralization, yonke le acid reactant le base, so the pH is 7, right? But then if le base isheshe yaphela, i-acid ingapheli, then it means we have an excess of the acid. But what conclusion can we make about the base? So in this case, the base is the limiting reagent. The base is the limiting reagent. It gets consumed completely. Or right? So it means if the base is the resulting solution will be acidic because corny acid is a cell. And then the last situation, you have a container yakho la, right? And uthela yonke le acid la phakathi, okay, and then bese uthela ibase yakho la phakathi. All right, and at the end of the day, the acid le react nale portion le ye base. So this was neutralized. The whole amount of acid is neutralized with this amount of base, right? And we can see utila we have an excess of the base. So what can we conclude about the resulting solution? The resulting solution should be basic and the pH should be greater than 7, right? So this is a basic solution. It means we have an excess of the base, right? So in this case, the acid is the limiting reagent, because iphele kuqala bese kwasala a portion of a base lab, then yenza the solution le ukuthi ibe basic. So here the acid is the limiting reagent. So we can see it is important for us to be able to determine the limiting reagent between the acid and the base in order to determine the resulting solution, right? So these are the three situations. We have a neutral solution whereby equal amounts of the acid reacts with equal amounts of the base, and then complete neutralization, right? But then sometimes we can have a reaction whereby we have excess acid and the resulting solution is acidic, right? And then the last situation, we have an excess of the base, all the acid has reacted, and the resulting solution is basic, right? So remember, we are still doing neutralization reaction, the reaction between a base and an acid. All right, fine. So let's look at an example. Say we want to react hydrochloric acid, which is our acid, right? And we are reacting it with sodium hydroxide, which is a base, right? And this would give us salt and water. And the salt is sodium chloride and then H2O. So we have to check whether it is balanced. We have 2 hydrogens on the left, 2 hydrogens on the right. one chlorine, one sodium. So, and then the oxygen, one oxygen. So the reaction is balanced, right? So we are just giving an example, and we want to determine the resulting solution, whether is it neutral, acidic, or basic, right? Okay, so let's formulate a statement. Let's say hydrochloric acid with concentration 0.2 mole per cubic decimeter. So we have our concentration here, which is 0.2 mole per cubic decimeter of volume 10 cubic decimeter. So we have our volume to be 10 cubic decimeter. So this hydrochloric acid reacts with sodium hydroxide of concentration 0.1 mole per cubic decimeter in a volume of 5 cubic decimeter. All right, so remember, this is a neutralization reaction. Why? Because we have an acid and a base reacting to produce salt and water. And from the statement that we just formulated, we said a concentration of 0.2 with a volume of 10 of the acid reacts with concentration of 0.1, volume of 5 of the base, which is sodium hydroxide. So the question is, determine whether the resulting solution is acidic or basic, right? So that is the first question that will be answering, which is determine the resulting solution, whether it is neutral, acidic, or basic, right? And the second question, determine the pH of that solution, right? If it is neutral, then we know that the pH will be 7. If it's acidic, the pH will be less than 7. So then it means it can be 1, 2, 3, 4, but as long as it's less than 7. Same thing applies to the base. It can be 8, 9, 10, as long as it is greater than 7, but it shouldn't exceed 14 because the pH range from 1 to 14. All right, so for us to determine whether the resulting solution will be neutral or the resulting solution will be basic or neutral, or acidic, right? It means we have to determine which substance is the limiting reagent, right? If the base is the limiting reagent, then it means the resulting solution will be acidic, which is situation number 2. But then if the acid is the limiting reagent, then it means the resulting solution will be basic. But if both acid and base amounts are equal and they completely react with each other, then it means the resulting solution will be neutral, right? So how do we determine the limiting reagent? We first calculate the number of moles of the acid, right? And the number of moles of the base. Okay, so how can we calculate the number of moles of the acid? Concentration formula, C is equal to N over V, right? Remember, we are calculating the number of moles of the acid. And then concentration is 0.2. This is equal to, we want to find the number of moles, and what is the volume? The volume is 10 cubic decimeter, right? And it means the number of moles, these are the number of moles of the acid which are reacting. So we have 2 moles of the hydrochloric acid available, right? So this is the first step that you need to do. And then you calculate the number of moles of the base. right? And looking at the information that is given, we're given concentration and volume. We still apply the same formula. Concentration is equal to concentration is equal to N over V, right? And concentration is 0.1 and the volume is 5, right? Then that would be 0.1 times 5, and that is 0.5 moles, right? And then now step number 2 in determining the limiting reagent, we want to check how much of the product can we get from hydrochloric acid and how much of the product can we get from the sodium hydroxide, right? The one that produces less product, it is the limiting reagent, right? So let's see, let's choose maybe this product. We want to check how much of this product can be produced by hydrochloric acid and how much of this product can be produced by sodium hydroxide, right? So that is step number 2. So we want to check the amount of sodium chloride that can be produced by hydrochloric acid, right? So we look at the ratio. The ratio, we have 1:1. So that is 1:1. And we do have the number of moles of the acid, which is 2 moles. And we're trying to find the number of moles of the sodium chloride that will be produced, right? And this would be 2 divided by 1 and then times 1. So it means we have 2 moles of sodium chloride that can be produced by HCl. Okay, and then now let's look at the number of moles that can be produced of the sodium chloride by the sodium hydroxide. The ratio still, this is 1:1, so the ratio is still the same, right? 1:1, and we do have the number of moles of this. We're trying to find the number of moles of the sodium chloride that will be produced. So that would be 0.5 divided by 1 times 1, and that is 0.5 moles. So let's come up with the conclusion now. Hydrochloric acid, the amount of moles that we have of the hydrochloric acid can produce 2 moles of sodium chloride, right? But the number of moles that can be produced of this sodium chloride by the sodium hydroxide is 0.5. So it means sodium hydroxide produces less. Sodium hydroxide produces less because it only produces 0.5, but hydrochloric acid produces 2 moles. So sodium hydroxide produces less products. It produces less products. Therefore, sodium hydroxide is the limiting reagent. So now we can come up with a conclusion that we have a situation number 2, whereby the base is the limiting reagent, right? And what does that imply about the resulting solution? It means we have excess acid, right? And if we have excess acid, then it means the resulting solution is acidic. So I hope it's clear. And then we can also conclude that HCl is in excess. So now we are done with question number 1. We can conclude that resulting solution is acidic, right? Because the base is the limiting reagent. All right, so let's answer question number 2. What is the pH? Then we do know that this is acidic, but what is the pH? Calculate the pH or determine the pH of that resulting solution, right? Okay, so now from the formula of the pH, we know that pH is equal to negative log concentration of the hydronium ions, right? Or we can also use the pH is equal to negative log concentration of hydrogen ions, right? So this is the formula of the pH. So for us to determine the pH, it means we have to find the concentration of these H plus inside that solution. And where are these H plus coming from? Abuyala from the hydrochloric acid, which is in excess. So we have to determine the excess hydrochloric acid, right? So how do we determine the excess hydrochloric acid? We had the total hydrochloric acid, right? That reacted. No, I mean that was supposed to react. We had the total available, but only this portion reacted. So it means for us to get the excess, which is this portion, we'd say the total which was available, the total number of moles, minus the number of moles that reacted, right? We have the total, and the total that we had, 2 moles low. So we had a total of we have a total of 2 moles of this hydrochloric acid, right? So now we have to find how much reacted so that we can say load 2, which is the total minus le reactive, then we can get that excess number of moles. But we told njani le reactive, ain't reacte na le sodium chloride, na le sodium hydroxide. So you use this sodium hydroxide to determine how much of the hydrochloric acid actually reacted, right? So we want the HCl that reacted using our limiting reagent, and the ratio is 1:1 there, and we're trying to find the amount of HCl that reacted, right? But we do know that 0.5 moles of the sodium hydroxide reacted, and x way to 0.5 divided by 1 times 1, right? And that will result at 0.5 moles. So now we do know that only 0.5 moles of the hydrochloric acid reacted, but we had a total of 2 moles. We had a total of 2 moles, what we calculated up here. So now let's determine the excess hydrochloric acid. That would be the total, which is 2 moles, the one that we calculated initially, and then this will be minus 0.5 what reacted, and then EXCA2, it's 1.5 moles. All right, so since now my number of moles are the excess, right? So sifuna ukubheka ukuthi le excess yethu izoproducer our hydrogen plus abayingaki. But we do know that hydrochloric acid is monoprotic, so it can only produce 1 hydrogen ion, right? So the ratio is 1:1. So it means the number of moles of the hydrogen ion will be equal to the number of moles of HCl, right? So it means the number of moles of the hydrogen ion is equal to 1.5. So now, we formulate the pH, we need concentration, not number of moles, we need concentration. So we need to calculate the concentration. So C is equal to N over V. C is equal to number of moles, we have 1.5, right? And then the volume, so now nasisiza la kule volume. Remember, si ede lama volume I2. Si ede this 10, right? So add another 5. So it means Begno 10, so add no 5. So the total volume manje, it must be 15 cubic decimeters. Right, so it means that's for a concentration here today. So divide ngalo 15. So that would be divided by 15 cubic decimeters, and then the concentration would be 1.5 divided by 15, and that would be 0.1. And remember, layer concentration, this is the concentration of H plus. So same thing, this is the concentration of H plus, which is 0.1 mole per cubic decimeter. All right, so now we can find the pH. pH is equal to negative log concentration of hydrogen ions. pH is equal to negative log, what is the concentration? 0.1. Then the pH would be negative log, of 0.1. So our pH is 1. So, and we can see that this pH is less than 7, and the pH here to 1, and that is acidic. So it's a lot of information to process, but by practicing what's happening, we are just reacting an acid and a base and determining the resulting solution, and we also determine the pH of that resulting solution.